So thanks again for everybody. I hope for coming after lunch. I hope that if you hope that you had a good lunch. I thought it was pretty good. This is the second in a series of three sessions that are related to metadata evaluation and related items. One of the things that is interesting to me these days is the role that repositories play. And we talked about, metadata rubrics or evaluations for quite a while in a lot of different contexts. And a lot of times we're talking about individual metadata records or cohorts of metadata records that are uploaded to a repository or something like that. And now we have, there are a lot of really big repositories around. And things like in Data One, certainly the CMR and NASA, sort of big, sort of multidisciplinary things like DataCite that we talked about a little bit in the last session, and Crossref. Crossref has over 110 million registered items now, so there's some big players out there, and there's a lot of things a lot of new ideas that are emerging in metadata land. Things that we in this room understand we need, things like identifiers, things like elements that might support the FAIR principles. And back in the deep day, when I was doing metadata at NOAA, like earlier than many of you got involved in this, we would say, okay, well, we've got these 200 metadata records, and now we're going to change this policy, and from now on, we're going to do this. Because from now on was a bigger number than 200, at least we hoped it was, and in some cases we were lucky. But now what's out there is 110 million or 17 million, or Matt's talking about 800,000 records in Data One, and things like identifiers. We all understand that identifier. How many people here don't have orchids? Come on, nobody. Okay, well, this is an unusual community because there are a lot of communities that don't have orchids, and there's a lot of publishers' policies and things like that mean that those identifiers don't get in, don't get into the metadata. So what we wanted to talk about today was sort of how metadata evaluation can get used in repositories, and what sort of level of evaluation do we do to try to take advantage of these evaluation techniques that we're building and use them to the benefit of the repository users. So Matt's going to talk about Data One. Margaret will talk about, I guess, would you call it EDI now? LTER2. Yeah, LTER. And then I'm going to talk, Daniela Lowenberg and I are going to talk a little bit about Dryad, and we hope that you enjoy it, and questions are encouraged. We have a number of people online, so if we do questions, we may have gotten the microphone improved from last time, but anyway, so we'll start with Matt Jones and Peter Slaughter from Data One. We say 20 minutes?
Yeah, 15 and 5.
Yeah, we have time for discussion.
So today, like Ted said, we're going to focus on 3 repositories and their sort of experience. And the goal that we had was to basically talk about 3 different things. So evaluation of metadata within that repository, tooling that might be more generally useful to the group, and evolution of metadata dialects and how metadata dialects affect what we do within those repository contexts. So I'm going to start today by talking about the Arctic Data Center. The Arctic Data Center is an NSF-funded repository out of the Office of Polar Programs, and it's responsible for all of the data that's associated with NSF-funded grants and awards in the Arctic region. And so investigators are required to deposit data there, and we have a curation staff that basically handles that and manages that. It's considered a long-term archive in the sense that NSF is committed to its it's archival responsibility, and we can expect that to continue. That's one example of a repository within the Data One network. And I'm also going to talk a little bit about the more general tooling that we have within the Data One Federation and how we're thinking about how we can scale up support for metadata evaluation across the network in a way that makes it simpler and more efficient for individual repositories to do what they need to do. And I'll put that in the context of the Arctic Data Center and what we do. I just said that. At the Arctic Data Center, there's a number of different functions that we support. So data archival is one of the major things. We are also a data discovery portal for the particular data that we operate, but we share our data also with Data One and other federations that have interest so that it's more broadly accessible. We build tools and infrastructure. We have a training and outreach program, and we have a data rescue program to find historical data sets that are, oops. And we have a data rescue program that we use to basically reinvigorate data sets that might have been around from historical periods of time but don't have adequate documentation to be really useful. And then finally, we have a support services division that really handles our curation and interacts with investigators. So collecting data from a set of researchers who are mandated to deposit data in the Arctic Data Center is definitely a challenge. People are willing, but oftentimes don't have significant time to invest in the documentation and archival of their data. But because it's such a hard requirement through the Office of Public Programs that people deposit, we have a lot of leverage to ask people for higher quality information than they might naturally have provided just on their own. And so the support services team is constantly trying to iterate on how we do things in order to make it easier for investigators to deposit their data while still making sure that we get a quality product. So we've built basically most of our investigators use a web-based application for metadata management, and I think many of you would probably have something similar. We also have scripted submissions in R and Python for projects that have much larger data sets. So we have some data sets that are generated through automated means where people need to be depositing, say, sensing data on a regular basis. And so they'll develop scripts that access our system directly. We've built a set of tools around metadata checking that I described this morning from the Metadig project. And so that set of tools allows us to create a set of automated quality checks that every data set gets passed through on submission. And then we use that as sort of our preliminary filter as we work on getting data sets in place. And then we have a manual reviews cycle. And so we have a team of about 6 data curators that review data sets as they come into the data center, and we spend anywhere from 1 to 2 days to 2 to 3 months working with each PI on improving the metadata associated with their submission, depending upon where they're starting from and how big and complex their data set is. And then once that's in good shape, we then will approve that and assign a DOI for posterity. We support versioning, so if PIs have additional data that comes into the next year, it's much easier for them to deposit because they're really just appending to an existing data set and changing a few things. So this is basically a brief schematic of kind of our process. Submissions come in, we generate a ticket system, a bunch of people get notified. We have this sort of ongoing interaction with the PIs, and then we approve that and issue a DOI. So I'm guessing that this kind of workflow is really similar for many of you that have a curation workflow for a repository as well. The details probably differ, but the same sort of components are there. And so I've always wondered, how can we automate parts of that process so that across repositories we can share some of that infrastructure and not have to build it ourselves. So build those support systems that we're all doing in similar ways. So one of the ways that we've been working on doing that is to try to build this relatively generic automated quality assessment tool. And so I talked about this tool this morning with respect to FAIR, but this screenshot here has what we call the Arctic Data Center Suite. So in addition to the types of checks that we were doing this morning, we have a number of specific policy directives that are specific to the Arctic Data Center. So there are licensing requirements, there are requirements about the types of details that are required that might go beyond basic metadata, and we've encoded those into a set of checks. And so we require that when somebody submits metadata, the first thing our data team does is looks at this quality report that comes out for each data set and evaluates whether or not they've passed those. And occasionally there will be a situation where one of the checks doesn't apply to a data set, so there are sometimes exceptions, but for the most part, people have to get 100% of the checks across the board before we even move on to the human curation part of the process. And that has sped up our curation immensely. What would be nice is if that kind of if we had agreement across repositories on what all of those different policies and approaches are, so that we could share the development effort associated with building an engine like this. And that's what we've been trying to do through Data One. So this is an example of kind of a list of all the types of checks in the report that the investigator gets back. So it says things that, like, at least one award number was found. All award numbers were found in the NSF database, so we do a lookup to make sure that their awards are actually real. A creator was present, a contact is present. The abstract's 105 words long, which is sufficient. The identifier is a DOI, and that looks like a DOI, so that's a good thing. Keeps going like that. And then there are other places where there are either warnings or failures, where somebody has, in this case, a long title. In this case, we're giving a warning when titles are too long. We like for them to be relatively short and readable, or where, in this case, a sampling description was not present in the methods. So we don't really understand the sampling protocol associated with this data set. And so these kinds of checks are run routinely, and basically as soon as somebody submits a data set, every version gets checked over and over again. I already talked about the FAIR suite in this collection report, but in addition to the individual data sets, we basically get that whole collection report for all the data sets in the repository. And so what we'd like to see, within Data One, we'd like to see a system where we can run the FAIR suite that we talked about this morning as sort of a generic sort of assessment of whether or not a data set is of high quality, but we can also run custom quality suites like this Arctic Data Center suite, so that whether we're talking about the Arctic Data Center or the KNB or ESS Dive or other groups that might be part of the Data One network, we can reuse the infrastructure that we've used to build this quality assessment work across those different systems. So I want to talk for just a minute about what that quality engine infrastructure looks like. The problem that we have when we try to apply this at scale is that within Data One, as a federation of 42 member repositories, there's a lot of metadata and a lot of metadata churn on a daily basis. So although we have 800,000 data sets, those data sets have many, many versions. And so, when somebody's doing metadata editing, say within a web-based application, they might run through 10 versions in 10 minutes as they click save, 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 save. And we're trying to assess the quality of the metadata as they move through that process and be able to provide them with guidance on how to make the metadata record better. And so our challenge is to try to quickly have a system that can quickly process millions of metadata records and the versions of those for many different quality suites, for the FAIR suite, for the Arctic Data Center suite, for the KNB suite, for all these different recommendations, and repeatedly as those suites change. So if we update our Arctic Data Center standards and we add 4 new checks, we want to rerun our quality assessment on all of our data and metadata. So we want to be able to do that quickly. And so that sort of permutation, that set of permutations, means we have to have a large computational engine to be able to do that all at once. So what we've done is we've built a highly scalable system based on Kubernetes, where we have an automatic queuing system that every time a new version pops into a repository, it gets queued into a list that says these things need to be processed, that detects the new metadata versions. And then we have a large cluster with hundreds of CPUs available to basically take those off and process them in parallel. The nice thing about all this is that all of the computation for each of these versions of each data set's can be run completely independently of the others. And so from a scalability perspective, throwing more hardware at it works fine and is a reasonable solution. And so we've built this system out, and we can process thousands of metadata changes in less than a minute. So when people are basically across the Data One network pushing new data sets in from all the hundreds of different sites and clients they're using, we can hopefully keep up with the system. And so this is a simple architectural view of the way we've built the tooling around metadata evaluation. We have a set of data repositories that are publishing versions as they happen through an API. The Data One API then talks to this controller that creates basically a list, and we have this scalable set of Kubernetes pods that go out and do the computation. The key to this thing is that we've defined all of the checks as atomic checks that get run on each metadata document. So each piece of computation is completely independent of the others. And then we just aggregate all the results up into the resulting report that gets sent back and displayed to the researchers. So right now we've basically processed the 687,000 EML and ISO docs, but that really represents a much larger number of versions, and about 4 million versions of those documents have been processed to now. So that just kind of gives you an idea of the metadata evaluation sort of framework and tools that we use in the Arctic Data Center and where we're heading in Data 1. And I'll turn it over to, I guess we have probably time for a couple questions if there are any. There's still 3 minutes left on my timer here. So, and then we can turn it over to Margaret. So any questions?
Okay.
Your slide set up.
I'm just curious how you distinguish between a warning versus an error in your checks. I mean, is there like a hard line there, or is it kind of dodgy?
Yeah, in the system that we've developed, that's a definition in each suite. So when you define a suite of checks to be checked, you can say whether it's required or optional. If it's required, then a failure of that check becomes a failure. If it's optional, then the failure of that check just becomes a warning. It's basically saying this is missing, but it's not required to pass the suite. So simple.
It looks like Matt has a couple ringers in the audience. He put it out here to ask questions.
It says it's got a problem.
We're trying to stump him, actually. But, so do you have a metadata attribute you use to track the status of a data set? Is it undergoing these different stages of review and ultimately reaching an approved data set?
So we do track that in the Arctic Data Center through a separate system. And it ultimately, when it gets in the Arctic Data Center, when things are approved, gets written into the metadata record at the end. But we have a whole separate ticket system because there's a series of sometimes hundreds of emails of correspondence back and forth with the PIs, and we record that stuff too. So we mostly use a ticket tracking system to track the in progress changes. And then at the end, it all gets written into the final version of the metadata. I'm not sure if that's what.
Yeah, because we were talking this in the earlier session about it would be really nice to have, as part of a metadata record, the level of curation or review that a data set has gone through to increase the understanding of potential users about fitness for use or quality, overall quality of the product.
Yeah, it would be great. And I think that like the metadata maturity model that Yu Peng was presenting yesterday, that kind of a taxonomy of metadata would be a great way for us to potentially classify where things are after they've come out.
I can't get the whole file.
One of the nice things about the
use
ISO
mine.
metadata standards is that they have this idea of scope, and the metadata can apply to a lot of different scope, from collections of things to specific attributes, and also to the metadata. So it's possible in an ISO metadata record to include not only lineage of the metadata, but quality of the metadata and the tests that you've used. So there is a standard mechanism available for recording that kind of stuff in the metadata record, which would be interesting to see if that worked.
Yeah, you can't because there's people in the
Well, you have an opportunity to be the first, Bill, and that never has stopped you before. There probably are some, but I'm not sure. I don't know them.
Hi, Matt. I was wondering, support and service, how, and when you're working the research and that could last for months, which I totally understand. How much do you work with the researcher to change or modify the data set to make it in a more archivable format versus just what they give you, which is typically how they might analyze it or something?
So we have a set of guidelines and recommendations that they use non-proprietary formats, that they have a certain level of, organization to their data sets. So we do try to evaluate that. We do not restructure their data for them. That's their job. We don't have the resources to basically intervene at that level, but we do make strong recommendations. And in that process of having that conversation, people will sometimes push back and say, this is what's best for our community. And then we basically say, well, that's between you and your program officer. And sometimes that means that their reports get accepted as is. And sometimes it means that the program officer says, no, you need to make this open. You can't use this proprietary format from the sensor. That's not reasonable. And so they'll come back to us, sometimes disgruntled, basically saying, okay, we have to do it your way. And yeah, so we try not to end up in that situation, but so it's up to the researcher, but we do try to help. And we definitely provide a lot of feedback about data structure and organization, which is usually a huge problem, especially coming out of the Excel world. Like, so we do a lot of helping people dump stuff out of Excel into relational models and cleaning that up. Yeah. You all set, Mark?
Okay. Do you want to close that door? We do have time sort of in the schedule, half an hour or so at the end for discussion. So if we have more questions at that time, that would be great. Today during the intro plenary, Mike, I think it was, mentioned groups that have been working or co-locating their meetings with ESIP for many years. Data One and the Data One user group and now the Data One community group are one of those for 8 years. And Margaret is here sort of, she may not know this, but she's here representing LTER, the repository previously known as LTER, which is now EDI. And the LTER data managers have also been meeting. I think it started at the meeting that was in Frisco, Colorado 5 years ago. And so they've also been co-located. It's one of the nice things, a great opportunity for coming to ESIP and getting to know some of these groups that meet alongside of us. And Matt and Margaret both are representatives of those. So thank you for joining us. And
thank you.
Have a fun talk.
Fun talk. So great, I can skip this because Ted gave the introduction. So I'm going to talk a little bit about the EDI and LTER congruence checker for EML. It actually belongs to both these groups. Basically, all the development work should be attributed to LTER because of when it actually happened, and then EDI as a repository evolved from LTER in 2016 to serve LTER plus additional ecosystem level research projects. So similar data, long tail, very idiosyncratic, but described in EML. So this particular checker is focused on EML as a metadata dialect, and it's the only one we deal with. So actually that means it's an advantage that we can actually dive pretty deep into the schema itself. So again, these are Ted's three aspects that he wanted us to cover: the systems, the checking systems role in curation of data and metadata, the supporting tools and infrastructure, and how do we motivate and measure evolution of metadata in our case, not so much the dialect itself. A little bit of background. Most of this work dates back to almost beyond a decade. By the mid-2000s, there was an LTER data repository with thousands of data sets that were available. Secondary use of the data in these was increasing, particularly for synthesis, ecological synthesis, and we had a set of narrative recommendations for how data should be handled and contributed to a repository. And we also, a lot of us recognized that the EDI schema itself was very granular and really well suited toward automatic processing. So that had been attempted in a lot of cases, but we discovered a few things when we tried that, and one was that metadata was often incomplete, and the data meta and metadata were not tightly coupled. There was a lot of incongruence between the two. There wasn't a good way to know that, yes, this is indeed the data object that it's supposed to be. So clearly the narrative recommendations were not enough to nudge people in the direction of this preferred behavior. So we needed a stronger, different mechanism and stronger to provide more usable feedback on the data and metadata congruence and its potential usability, particularly for this secondary use. So this, as far as the role in metadata curation, data managers themselves, this feels weird, I hope my voice isn't changing volume here, were involved in all the initial design of the system, and a working group outlined the basic requirements. First of all, that they were anticipating already that the checks were going to be added over time. People are always going to think of new things they could do to look at data, and that needed to be accommodated. And they also needed a way to be staged so that people wouldn't be surprised by new additions. They thought that the configuration should be customizable for different communities. We recognized right away that some checks probably would deny insertion to the repository. That was just kind of a given, that some things were going to be deemed not usable, but those should be addressed first so that people would know as soon as possible what were going to be the barriers. And that all of this material needs to be presented using HTML so that you can have some kind of a reasonable interface or reasonable viewing. So you can imagine that all these kinds of recommendations suggest that there would be several different typologies that checks would have to be categorized according to. And so this is the way, and one other feature that was important was that the way that LTER had operated at the time, and this is in about 2009, you'll see later, we don't operate the way that Matt was describing for the ADC, where you submit, and then see an evaluation. We wanted a two-mode system where you could evaluate before you put your data set into the repository. And so there are two modes to this checker. One is that you can run it as an evaluation system, in which, and in that mode, the code actually goes as far as it can in evaluating the entire data set before it fails. And which is highly useful, because if you've ever validated anything with an XML schema, you stop at the first error, and then you fix that one, then you go back and do it again, and then you make the second error. But this evaluation mode means you can see a lot more problems right at the beginning. And then in the harvest mode, when you actually are uploading a data package, the system stops at the first error, and that just saves time. So this is the kind of an interface you get. The evaluate reports are not stored more than 6 months, I think. The upload reports become part of the data package. So they're there forever. And so that means they can be mined and analyzed. I'm not going to talk much about infrastructure because I am not a programmer. But this uses a community resource called the Data Manager Library, which is written in Java, which is part of the quality checker unit of this system called PASTA, which is the repository software. The report itself is an XML record. So you can see some of these elements, names here refer to the typologies, and I'll show you a little bit about that in a minute. So the checks themselves are defined in the same structure, and then it's used to hold the report content as well. So right now there are 41 checks that are implemented across these multiple typologies. There's 2 of them I've kind of just showing you that how they're distributed among a couple of them. One is this idea of packaging aspect. In the FAIR session this morning, and in some other checkers that you will see, very often they only look at metadata and they look for presence. But because these data sets are of particular interest to synthesis groups, we really needed to have congruence between data and metadata. And so some checks are related more to the congruence of those 2 aspects, and not just a simple metadata presence. And then the working group asked us to justify every single check against some policy. And so we came up with 4 policies here that we use for justification, whether a check was important for workflow, for discoverability, whether it was recommended in the narrative best practices, or was required by the PASTA system. And there is overlap between these. These are mutually exclusive and exhaustive categories, we hope. And then here's one more. This is the typology for response behavior. There, of the 41 checks right now, 16 of them actually would deny entry into the repository, but they're really pretty carefully considered so that we only reject data sets that are unusable. And by unusable, we mean things like the schema has to be valid in order for it to be usable. If the schema is invalid, you can't do much else with that metadata record. It has to have a valid identifier. It has to have a resolvable data URL. We saw lots of metadata originally that did not have that. Checksums and/or file size need to be congruent, because if they're not, you may have the wrong data entity, no matter what the metadata says. Entity names need to be unique, and this last one, the tables have to have this, every row in the table has to have the same number of cells. And then the other response behavior that's most typically we see is this valid or warn. And that just means that there's something that we suspect is an issue with this data set, and you're recommended to go back and look. It is possible for checks to move between different response behaviors. It may be at some point in the future, a check that's categorized now as a warn could be recategorized as an error, but that would be up to the community to decide. And then there's a handful of checks where they simply return something informational about the data package, and those are classified just as info. They make no decision about its value. So here's the timeline of the checks we have implemented, and there's 3 categories here. The bottom bulge is what's been implemented now, and you see that's at 41 now. There's also a few events at the bottom. Of course, the big bulge is when the repository was first introduced, so you see the biggest peak in check development there. We have actually in our main list of proposed checks almost 100, but less than half of those have been implemented, and about 3/4 of them are what we would say fully described. But how we'll add them in the future will depend on a lot of different constraints. So you can see the corpus of checks is growing a little bit over time. And now I'm going to give you some of the results. So because these are XML records that can be mined, now we can look at the way that every data package has responded to the checks since 2013. So this is a pretty simple plot because checks have different parts of the metadata package that they apply to. You can have different rates depending whether you're looking just at the data tables or just at or the entire metadata record. But what you can see here is that most data packages were hit by less than 5%, or excuse me, the rate of warns per data package is less than 5%, and very few have more than 15%. And this is one of my favorites, is that what this is telling us is the same warn rate over time by month for the first 3 years of the POSTA repository, and that it actually is dropping. So people, the first few data sets they put in, they might have had some problems, but they figured out how to deal with them, and the rate has actually dropped. This is another way to look at how the metadata has evolved over time. Since from one of those earlier plots, you saw that there have been additional checks added since the first ones came out. And what you see here is that in 2017, we added 2 new checks for one to look at the integrity checksum of a data entity. And what you'll see here, if you look at it's the bottom row that has the white bar in it. I can't walk over there and point because I'll leave the mic. But nobody was using this element in any EML at all. Sorry, I should back up. This plot is the number of LTER sites, or actually all contributors, using a metadata element every year since 2013. So you can think of it kind of like a population study where the presence of a particular EML leaf node is like a trait of a cohort, an age cohort of a population. So if you look at this line for authentication, which is where the checksum lives, you see that there were no instances of checksums found up until 2017, and that's when the check was added, and people right away responded, and now we have up to, I think it's like 18 checks, 18 contributors are now putting in that authentication element. If another one that's relatively new is funding, NSF has asked that they be able to query repositories to see what data sets go with what funding codes. So we added a check for project funding. And so now you can see that early on, only a handful of sites were using this element, but after we added the check, it went up. Another thing that we could do, and this is more about evolution of the checker itself, is that we could add another typology. All of the original check design happened before FAIR was even a thing. So now we could go back and add the FAIR principles to as another typology, and this is the first pass at how that would look. And because we have such a high focus on congruence and reuse, it looks like most of the checks they're going to fall under interoperable. There's a second reason for that, and that's basically that almost every congruence check is actually more than one thing has to be checked. So you start to group these together. If you were going to say, look for something like jagged tables, it actually takes, I think, 5 different checks to do that. So those aren't one check, that's 5. So future, we already can support 2.2, which isn't out quite yet. And I said maybe, but I think probably the working group will get back together and talk about the FAIR principles and whether we should be adding a typology. We've also talked about adding another alert level between info and warn, so that people might see, they might pay some other different kinds of attention to different checks to see, if other things that are interesting about their data that they haven't noticed yet. And there's a couple papers. If your learning style is reading instead of listening, go ahead and look at these 2 papers. They'll tell you about the PASTA system and more about the typology and the kind of the social aspects of how all this developed. And that's all I have. Good questions? I think I forgot to turn my timer on.
Thank you, Margaret. Questions for Margaret?
It's the first time I've tried this microphone. Pointed at that thing. All right. Woohoo. How's that? Good? Okay. How do you check and understand the congruence between the data and the metadata records? How do you evaluate that?
So the data table actually is loaded into Postgres using the metadata to create the DDL. And then each check has to be designed pretty specifically. For example, one of the ones that was added recently has to do with the date time formats. So the date time format is described in the metadata, but the data is in records. So the data table's loaded in, typed as a date, and then literally the format string that was given in the metadata is compared to the format string of every record. And if they match, good. If they don't, you get a warn. It's not an error. It's just that they'll just say that you have a date that doesn't match. Yes, so the metadata is adequate to do quite a bit with the data entity.
Sort of an interesting concept, right? Like using the metadata to actually read the data. What an idea.
It's crazy, huh?
Yeah. Any other questions here? And we will have a discussion later. Okay. Thank you so much, Margaret.
You're next, right?
Let's see. Signed in. I don't think we need to sign in, do we? Yeah. All right. The final talk, we sort of have a progression on the order of these. We talked earlier this morning about types of tests. And we talked about presence tests and then more complicated or more, I don't really want to use the word invasive, but I will. But so the data congruence is an interesting thing where we're actually looking at the metadata and reading the data and interacting with the data providers. And as Matt mentioned, in the Arctic Data Center case, they're also doing that. And we're hoping in the tests that we talked about this morning for FAIR to try and get these convergence tests in. But when you're trying to process a few 100,000 data sets, the congruence test can be expensive from a performance point of view. But so if you were here this morning and you saw the Git issues for our FAIR ideas for tests, feel free to add things in that you think you want to suggest that are more like congruence tests. The final talk is Danielle Lowenberg from California Digital Library and I. And in this case, we get maybe even more invasive because we're actually creating new metadata and augmenting existing metadata records with new metadata in as the Dryad repository moves to California Digital Library for infrastructure. So this is sort of the most invasive of or the most effective, the most far-reaching. Maybe invasive isn't a great word, but anyway, this is Daniela's second ESIP meeting?
First.
Third. So
First.
she's sort of
First.
new to the
Yeah.
ESIP community. So can we please welcome Danielle over to ESIP and to this talk.
Thank you for that comic entry. So yeah, I'm new to the ESIP community-ish. So I know a lot of you from RDA and Force and other communities that we've worked in. I work at California Digital Library, but for those of you who have heard or haven't heard, it's been a year now, so I think more have heard. We've partnered with Dryad. So half of my role is actually that I'm the product manager for Dryad. So that's why this affiliation here. So I'm going to give a little bit of background on why we embarked on this project. Ted will explain what happened in the project, and then I'll show you what it actually looks like when we changed it in Dryad. So the problem is that we've taken on Dryad. We're going to relaunch this new platform, and we were looking at it, and there are 0 affiliations. So Dryad had never asked researchers, what's your affiliation? And we have none of that. And that is a huge problem because we can't really figure out anything without that information. So it's just one piece of metadata. And I know we've been spending time talking about FAIR and all of these things, but affiliation is massive. We can't think about what institutions are doing, the usage that varies in discipline at the institution. And we can't actually give metadata back to institutions without knowing that. And so Ted and I started working on this project. And what it all really entails is figuring out how we can get from no affiliation information at all for every Dryad DOI, so 28,000, it's about 90,000 researchers, how we can not only find their affiliation, but standardize their affiliation and load it into the new Dryad system, and so that we have an entire corpus on this. So you can see what Ted was saying of, it's a little scary because we're creating completely new metadata just from searching. It's not something that researcher is entering themselves. And so the way that we're doing that is that we knew that we had no affiliations in Dryad, but for the last 10 years, every single data set in Dryad had a related article. So we went to Crossref and we did a poll for every single article DOI that's related to Dryad to get the affiliation. And we got half. So not only was it data repositories, but publishers also either weren't collecting the affiliations or weren't sending them to Crossref, which actually makes sense because there's been no standard for affiliations. So of that half we got, they are messy, and none of them are actually standard. We also then, so for the other half, we're thinking what are other open sources? So should have added to this diagram, but PLOS, luckily enough, opens up all their APIs, Unpaywall, although they get most of their information from Crossref. PubMed has a little bit. So we're just pulling from all these sources, trying to get these raw affiliations. And then once we have that, that's not the final goal, because those could be a million different spellings of University of California, or it could never specify the campus. So how many people here have heard of ROAR? Cool, all right. So ROAR is a project that DataCite works on, and CDL, and Crossref, and actually Digital Science. And it's a project to have standardized affiliations for institutions. So think ORCID for your institution. And it's not something that a researcher ever needs to know about, because it's something that's a standard that we can implement. And that's what we're going to show later of what we've actually put into the system. There's a blog post about how we did it, and our code is completely open. You guys are welcome to take it from us. We were the first implementation. We have not released Dryad yet, but it's all on the staging site, so you can use that now. So anyways, taking those, then we had to get them a ROAR ID, and then we had to get them into the Dryad system, and then eventually get it over to DataCite, and so that in the end, all of this is with the rest of the metadata. And that is a big overview of it, and Ted can go into a little more detail.
Yeah, so I talked a little bit earlier about everybody in this room has an ORCID, and everybody in this room understands the benefits of permanent identifiers and using them. What's interesting about this diagram is we're using DOIs that are coming out of the Dryad metadata. We're using an identifier to try and retrieve affiliations, and then we're trying to reconcile those affiliations, which are pretty messy, as Daniela said, into other identifiers that we're adding back into the metadata. So getting identifiers into metadata is an important task for the next couple days at least, and maybe it'll take longer than that. But anyway, so how are we doing? There are these four measure here of how we're doing. Out of the affiliations, we found ROARs successfully for 79% of the affiliations that are in the data. Those affiliations are, sometimes they are comma separated, sometimes they're not separated, sometimes they're partially comma and partially semicolon, sometimes they're semicolon. So there's a lot of little tokens in those guys that we tried to retrieve and hopefully get better results. So there's more affiliation tokens than affiliations, but for the set of tokens that we had, we ended up with 67%. For the DOIs, we got some ROAR, at least one ROAR for 91% of the DOIs. So I think that's a pretty good number. And we got some ROAR for 85% of the authors. So what did you say, 90,000 researchers? So out of those 90,000, we now have identifiers for about 85% of them. So I wanted to reemphasize something that Daniela said, that in the beginning, in 2018, last year, there was no affiliation information in Dryad. So this is a situation that we've talked about a little bit in the last two sessions of dialect evolution. We have a dialect, it's called Dryad, it's pretty thin, but the reason that it's thin is because the assumption was that people were reading papers and then they went from that paper to a data set. So the information that was in the paper, really we would think about as essentially unstructured, detailed metadata for that paper. So most of the metadata that was created in Dryad was really just sort of for managing the connections between data sets and papers and stuff like that. And a lot of us have spent a lot of time, say Data One or NASA or NOAA or other places where we have metadata for data sets that people get the data and then they make papers. In the Dryad case, they made papers, they got data, and then they made the papers, and they put the paper was sort of integrated into it. So there's a reason there was no affiliation information, but then a new use case emerged here that Daniela mentioned. We now need affiliate. We understand the benefits of having affiliation information, and so we're really doing what I'm now calling metadata rehab. So we're like adding on affiliations to these data. And we got 52,000, out of 52,000 affiliations, we now have 41,000 ROARs. Okay, so I think that's a nice number. And there's a lot of ways that we're trying to match this sort of messy text. And 44% of the matches with the ROARs are actually exact. Aurora is just an organization. It stands for a Research Organization Registry. It's just an identifier for University of California in Davis or a lot of interesting, my favorite I talked about with Simon is the University of Bath Spa. and they have really good data site metadata, by the way, Trish. They're really good. Anyway, so in 44% of those cases, we actually got exact matches with the standard names that are in the ROAR directory, right? The ROAR directory is an identifier and a standard name. So it's interesting. And the most common matches were exact, so that's good. So I'm doing a bunch of work with DataCite and with Crossref, and so these are some radar plots of percentages of completeness of things. But the important thing is that in DataCite, roughly 30% of the metadata records in DataCite have affiliation strings. None of them currently have ROARs, although DataCite is building those ROARs as they're evolving their tools. In Crossref, it's actually fewer. Crossref is bigger, it's 115 million registered things, but only 5 or 11% of them, of those actually have affiliation strings at this point. So one of the arguments that I'm making is that we need to start working with Crossref and with DataCite, and those repositories need to take more it's my opinion that they should take more active roles in getting these identifiers into these metadata records. And we should do it now and build the systems like Danielle will talk about, where we can build them into the future. So this is one of those situations where the past has gotten big enough that we need to do something about it, but the future will be rosy. Okay, so the challenges there are, Danielle mentioned that in Crossref, we were only able to get affiliations for about half of the articles. Fortunately, Dryad. Fortunately.
Я, наверное, когда минут через 10 поеду.
Fortunately, excuse me.
Понятно, я просто тебе утром позвонила, но потом ты не подняла трубку, я сообразила, что, наверное, еще раньше выехала, так что... А каким ты теперь едешь?
Okay, well, this is interesting.
Yes,
in the next room. Usually I wanted to thank them for bringing the band for me.
Yes. Давайте позвоню, когда поеду, ладно?
Oh, maybe it's online. Yes, someone is talking caller one, maybe. You might want to mute yourself. Look down lower. Oh, hey, Ryan, you might want to mute yourself, or Reza. Yeah, okay, cool, great, good. Anyway, only half of the articles had affiliations. Unfortunately, Dryad has curators. They're actually going through and, believe it or not, cutting and pasting things out of HTML pages. So they deserve a hand for that, because that makes my head hurt. There are affiliations that are just things like numbers, like addresses, or things that don't have names in them, or put affiliation here, things like that. What? My affiliation is Metadata Game Changers, and unfortunately, I don't have Aurora right now, but I'm going to get one. I could get one. You know, Daniela. No, the history of Aurora is an interesting one. We can talk about that during the discussion. Yeah. There's a lot of problems with character sets, and character sets are coming in from cutting and pasting, so the character set information isn't there. And then so there's letters that have umlauts and accents and stuff like that, and then sometimes they're misspelled with that, so that's sort of a mess. Organizations without RORs like Metadata Game Changers and maybe some affiliation of Simons. But then the other thing is that we're looking for partners that are committed to evolving metadata content and repository tools. And everybody here who's worked with repositories knows that as soon as you start creating tools, you start limiting the choices of what you can do with the metadata. And very few of the tools that we have support complete dialects. So even within a particular dialect, particularly if it's a comprehensive one like ISO or like EML, tools cause a lot of problems in terms of being able to migrate. So having a partner that's committed to evolving the metadata, the dialect and the content and the tools is important. And that's where Dryad comes in. And back to Danielle.
And for those who are asking, I heard the word governance and things. ROAR is a big project. I actually don't work on it. roar.org is the website. And if you ever you find that your institution doesn't have a ROAR, there's an email there, and there's also a public Slack you can join, and all the conversations about this are happening in that Slack channel, and the community calls there, so definitely join that community. But back to this one, so not only do we want to find all of this, but we want to be able to collect all of this going forward. And I don't do live demos, so this is all in screenshots. So this is the new system, and you can see here that I was typing in my name, and I started typing University of California. And what we've done is we're pulling direct from the ROAR API, and so we have the standard vocabulary here. So you can see that some things like San Diego have a School of Medicine, and so you can get different specific for it depending on what constitutes an organization. And so the great part about having to be able to pull this vocabulary is that we can actually ensure we're getting a ROAR. So when a researcher chooses this, in the back end, we have the ROAR name and the ROAR ID, and that's sent in the XML to DataSite and also available in our API. We can also capture it by just typing in UCSF. So a lot of people like to just type in the short for their institution. And in our former system, Dash, that looked like this, we just got a whole bunch of random things for affiliations. And so Aurora is able to actually not let that happen. There will, of course, be institutions that aren't in Aurora yet, so you can override this. But again, as Ted mentioned, Dryad has 5 full-time curators. So anytime something that's chosen that's not Aurora from this list, it gets flagged, and a curator actually goes through it and sees, is there Aurora? Should we email Aurora about adding this institution? So here, then we can have a couple of different ones for each of the authors. And then when it's published, we actually just know that whatever is listed there is a standardized affiliation. We have the Aurora ID. We can actually now do all these aggregations, see what's happening at institutions. And so everything that we're doing with TED to find these institutions and standardize them will be in the Dryad data sets when we go live for all the past DOIs as well. So we can actually just know that we've gone from 0 to about 90% for a lot of these things, which is important for us. So yeah, do you guys have questions?
Slow. Okay, questions? Let's see, we have 2:15, so we have a half hour for discussion. So at this point, I think we'll have specific questions on this project that would be fine, or there could be, we could also open up for open discussion.
So Daniela, with that,
I think if you stand up and sort of.
with that example you gave of the Roar app and the drop down, how do you deal with nesting? You know, you mentioned this University of California, San Diego, but you could just be University of California. I mean, does each sort of entity have a Roar, or I mean, how do you deal with that type of nesting?
Trisha, do you want to answer? I can.
Yeah, so I have a pretty loud voice. Is that okay?
No.
You don't have to do the twister point.
This is Patricia Cruz, by the way, the Executive Director of DataSite. So she's representing DataSite here. Thanks.
So thank you, Ted. And I love that salute earlier. It was priceless. So one of the things with Roar is we took the grid database. So DataSite is one of the developers on Roar, Research Organization Registry. And so that it doesn't go down to a granular level of affiliation. So I just want to say that up front. So if you're looking at for a department within the University of California, that's going to be difficult. But there are things to still clean up in the database, but it does have that higher level thing. So I would encourage you to go just look at the Roar database. Simon, do you want to say something?
Just that it's heterogeneous. I mean,
right.
I can find subunits of CSI row.
Right.
But none of the ones I've ever recommended.
Right. So
it's messy, but that's understandable.
Right. And for Roar, we're really depending on the community. Our next round of development will be on developing kind of that curator layer on top of Roar. So did I answer your question at all? Okay.
Heterogeneous, for those of you who don't know, when Simon says that, he identified opportunities for improvement. Karen.
Yeah, for those who can't see very well, where do you actually access the searchable Roar database? Because I can't seem to find it off the Roar.community site.
Can I what?
Roar.org. It's sort of like one of those backwards and forwards things.
Hi, Emilio Mayorga from the University of Washington. And just to follow up to that excellent question about or topic of subunits within a university, for example, I got curious and went into the the one box search box at Roar. And for my university, there are a few subunits. So, but I thought you said that they weren't supported. So this seems like idiosyncratic. There are 2 subunits: the Washington School of Medicine the Washington Cancer Consortium, and I can see that at my own institution, Applied Physics Lab.
So it's at a level of granularity that's not consistent throughout, but we think it's pretty solid and clean data. And I think there's room for improvement, but I don't want to take up more time of this topic talking about ROAR. And so maybe this is something that ESIP would want a presentation at some point, or webinar.
Yeah, I hadn't heard about ROAR. It's fantastic. Someone should have done this earlier.
But okay, so I guess that's the end of the session. ROAR is fantastic.
Okay.
That's the bottom line. That's going to be one of the takeaways. By the way, we should be recording those. Next question.
This doesn't need to be specifically about ROAR, but it is about affiliation of a paper versus affiliation of a data set. And I don't know to what extent this is done in other groups, but with LTER, typically when a professor publishes a paper or grad student, they list the author affiliation as their academic institution. But when we publish the data set associated with that paper, that data set's organizational creator is the long-term ecological research site. That is the NSF grant that funded the research. So it's related to the institutions, but it's a many-to-many. So yeah.
I think the reason that we have been following for this is just from an institutional perspective of, that's when they were at that time. We know that for sure, that when they were doing that paper in the data set, the timing works. And also for the same reason that Dryad Data CC0 the institution owns it. So we're just going to keep it. We know that it's a safer bet that we start with. It was their institutional affiliation of where they work, maybe first.
Yeah, so I mean, the history of ROAR, if you're looking for organizational identifiers, there's a few different lists that you can start out with. One is ISNI, one is, where's Steve? Who was there? Was the one that the Library of Congress does? EIAF? Yeah, there's that one. And then there's also GRID, which was created by a commercial entity, Digital Science. And ROAR adopted GRID, or Digital Science donated their GRID database of roughly 85 or so thousand organizations to ROAR. And right now it is that. It hasn't, the evolution of that and the improvement of the heterogeneity or breadth of it hasn't started yet. So right now ROAR is dealing with what we got from GRID. And that was a group that was willing to contribute to the initialization of the ROAR database. But so rather than starting from zero, ROAR decided to start with 85,000, which I think was probably a good decision. But some of these problems, GRID is part of Digital Science, which is part of Dimensions, and don't they own Figshare now or something? Yeah. So the population of the database was motivated by whatever they were motivated by in the past. But
no, I was just going to ask a little bit about one of the things we've seen sort of a big expansion of is the use of ORCIDs, the ORC IDs, the unique identifier for each researcher. Not all researchers sort of populate it further, but they do also, there's a place for, I believe, putting in affiliation and things like that, that might be sort of a useful place to sort of help mine in terms of being able to locate. It's one of those things where there may be, you're not going to get many false positives. You might get some lots of misses because people haven't populated that. But
I'm going to intercept before I know Tricia wants to answer it, but I'll say that that was our first thought, and Dryad requires ORCID for login when we launch. The problem is that ORCID sets everything to private, so it's up to a researcher to release that information. So it's very few that you can pull from. And then the second is that it wouldn't be standard. So ORCID hasn't put in ROAR yet. So what we've put into this system, because we're requiring ORCID for login, is that if they log in through ORCID, they come in and it's a completely public profile. We grab their institution and we run it through for ROAR, and then we put the ROAR in here. So the researcher doesn't know that's happening, but there's still a lot of work that has to be to get to here.
Yeah, they've been great about workarounds of solving problems like that. I think it's a great example, but ORCID is, early on, they were very involved in the identifier project, and they still are listening in, and we anticipate that they will begin to add those ROAR IDs.
Yeah, ORCIDs are really messy. I don't know if you ever, looked for someone's name and tried to find it. It's like makes affiliations look really easy, so every once in a while when I'm really getting, depressed about affiliations, I go and look at ORCID and I get psyched up. But the interesting thing about ORCID and Crossref, everybody here has an ORCID, didn't we? We did that, right? But if you look at Crossref, 110 million registered items, only 3% of them have ORCIDs. So the penetration of that's since 2017. Yeah, it might be 5% since 2017 and 3% before 2017, something like on that order. So even though in places like ESIP and places, bars where you guys all hang out, everybody's got ORCIDs, but the penetration of permanent identifiers into these big metadata repositories is really in its infancy. And that's one of the reasons that I'm arguing, or that I'm suggesting, that we need to start being more active, like this project that we're doing with Dryad, to try and get these identifiers in, because of course there's a cart and a horse and all that stuff. And if we can make, and then, identifiers for keywords and stuff like that, and the URI stuff that, Simon was talking about yesterday, and other people, Pierre was talking about earlier today. I mean, that's even worse, or even smaller penetration. So working with ORCIDs, working with affiliations and organizations and ROARs, or identifiers for instruments, or all of this stuff is going to be a challenge.
It seems like you're preaching to the wrong crowd with the ORC-IDs, because I mean, I think the LTR was pretty convinced from a discussion with Matt, and we all went and got our ORC-IDs and went back to our institutions and said, you guys ought to do this, and gave the few reasons that Matt told us. But then, a year later, it's like, well, we're hearing from them, why I've never heard anything about this ORC ID other than from you. How is it going to serve me? How is it important? We're going to wait until we hear it come from above. So how do we get that out to the researchers? Because we know about it.
I think it already I mean, most publishers are going to be requiring it, and a lot of the data repositories have been, sorry, I'm in the general repository world. Generals have been talking about requiring it too, but it's the grants that are going out to researchers too, more and more are requiring it. It's going to start being because they're finding out about it, not necessarily from us.
Yeah, and I would say that the fastest way we made the switch was just making our login, all submissions happen with it. So if you just switch your login to require an ORCID, then suddenly the problem goes away, because everybody has to have one in order to give you anything. So it's no longer an issue. I want to just make a comment about, I think this is really fascinating that we're diving deep into identifiers for people and for organizations, and how hard it is for us as a community to just get agreement on, can we find out, Joe Smith is actually Joe Smith. But in reality, this is the simplest of problems we have in metadata evaluation. The hard stuff is on the stuff we're talking about this morning. And so I just want to remind everyone, we don't want to stop here. This is kindergarten compared to all the metadata evaluation and consistency we need for scientific metadata.
At least it's early Montessori. How about that, Grace? Sure.
Give us something.
Yeah, it's but that's when and when you look at Crossref and you see this number of 5%, or even for affiliations, it's like 13%. The penetration is really small, and the publishers have a big role in this. So if you are an author on a paper and you're not the corresponding author, a lot of publishers only take ORCIDs for corresponding authors. And so if you're a second author or a third author or a 34th author, you know, if you're in astronomy and stuff like that, you know, go to those publishers and say, like, I'm trying to put in my ORCID ID, and where do I put it? And start putting pressure on them. And that's another tool that we're using with the evaluation through time. Matt showed some examples. There's some cross-ref stuff, and going to those publishers and saying, here are the good examples, and here are the platforms, the publishing platforms that they're using that have been successful. So the evaluation of metadata has a lot of utilization in a lot of different areas, and getting penetration of identifiers into the repositories is one of them. Questions, comments?
Still in the work topic, sorry.
Yeah, we're unplugging your network connection.
No, sorry that not graduated to first grade yet. I'm data manager for a regional association of IUs, the Integrated Ocean Observance System. And I'm giving that background because IUs, it's led by federal agencies, but one of its core goal is to bring data together from multiple sources, multiple stakeholders, which definitely go beyond academia or what we would call research entities. So for example, I integrate data from tribes, local and state agencies. The part of my excitement about Aurora is that we have encountered in our building our metadata that challenge of how to point to an authoritative list of institutions or entities. As I read the description of Aurora, reading research organizations caught my eye, because at least in my world, and I'm sure it's not unique, that many of you are not limited in your data facilities to research organizations. So now I'm somewhat despondent that Aurora will only address the organizations that are research organizations. And that's not my whole universe. So just wondering how either the Aurora community or broader community deal with that, with an authoritative list or two, I guess, research versus others. Anyways, still excited.
Any comments?
That's something that we, and when we put in their research organizations, we knew that it was going to be a little bit of a stumbling block for people for just that reason. For example, within DataCite, we have a lot of people who you wouldn't necessarily consider a research organization, but yet they're contributing data. And so take that word with a grain of salt. And again, if you organization that you want to see added to that, please send a message. Hopefully you're excited again.
Yeah.
I mean, overall, there's so many registries of organizations. I mean, you know, in government, the stock exchange, all of those kinds of things. So it's not feasible to be comprehensive. So.
Well, when you're using identifiers in metadata records, it's really important for the metadata dialect to be able to tell you what share of vocabulary was used to select this item from. So if you have an organization which might be a commercial organization, has an ISNI maybe, rather than a ROR, you know, getting an ISNI into your metadata record is equally important in that case. And one of the nice things that ROR is doing with the help of GRID is making connections between those. One other thing that we should also mention happened recently as a result of a meeting out in Portland is that a ROR property was added to Wikidata. So what that means is that, and I don't know if Simon, not this Simon, different Simon has populated it yet, but Wikidata is another big repository of names of all kinds of things, organizations, and you will be able to query Wikidata with a ROR or get a ROR back out for an organization that you find in Wikidata. So I think that's a big step forward for RORs. So, and the other thing about ROR is it came from the private sector, as I mentioned, into an open community. And the reason that the open community, you know, met for a few years to try and make that happen is so that we have a mechanism in an open community for dealing with these kinds of problems. And so no one is going to suggest that ROR is perfect. But we hope that it provides a mechanism for governance or improvement. Let's just say improvement. I won't bring in governance.
I just wanted to make a quick statement. I was looking for some organizations in ROAR that I use for R2R database, and one of them is Kongsberg, who does multi-beam processing. And in looking there, there's at least 2 automotive companies that showed up in Norway and in ROAR, and a gas station and things. So there are items that aren't research institutions. It's fairly open.
Because it says.
Yeah, I think I like Trish's suggestion that we have a discussion about ROAR at the next meeting. It's also a topic that we could, in the structure of PSIP, if we wanted to have a ROAR cluster, you could ROAR as that's another possibility, or we could deal with some of these questions if it's useful in the context of the documentation.
Yeah, when you talk about ROAR, you're not lying. Anyway. Anyway, I was going to shift things a little bit, and I was going to say that I just wanted to comment a little bit on the congruency checks, because the congruency checks actually tend to go fairly deep in the sense that they're making sure that the number of columns correspond to what you said. You know, if you said that it had that they were delimited by a certain delimiter, that they actually are delimited by a certain delimiter, and things like that. And one of the things that going into that level of detail means is that you're sort of eliminating the problems for people down the line, because you can either have everybody discover that you thought they were going to be commas, but they were really vertical bars on their own, or you can fix the problem early. And one of the things that's been really nice about having sort of data that's gone through a congruency check and a case where the data has actually been ingested into the repository is it enables things like code generation services, of where it's a one click to pull down our code to process the data, and or store SAS, or whatever you happen to like. We've got about 4 different variations on it. But that's the sort of thing that just isn't possible, or at least let me put this way, the reliability is greatly enhanced by the thing. Margaret's got answers for me.
Margaret?
I should have mentioned that, John, I'm sorry. We tried to do automated code generation at the very beginning, and we couldn't. But now every single data set in EDI has automated code for pulling it into R, MATLAB, SAS, SPSS, Python, and Python. So you just go to the landing page and there's the code. You can put it into existing scripts or run it on the fly.
Anna.
So just curious about your curation process. If you could talk a little bit more about that. You said you would go through and find, misspellings. There were things. How often were there things where you're just like, I have no idea what to map this to, or I can't map this to anything, or yeah.
About 9%.
9%? 9.5%? And then what did you do when that happened?
I sent them back to Danielle. So go for it.
We don't have an answer yet. We're still
Really?
mid-project.
Okay.
There's some things that there's no hope for. And then there's some things that are misspelled things, or, commas or dashes or spaces, or just, ridiculous little things. Most of those we've taken care of. Well, you could try and contact the author. Yeah, I mean, we've been working on the 90-10 rule, and as you know, the 10 is harder than the 90 in a lot of ways.
I'm just going to try to see, have you ever tried mining here? If the author's email addresses are available, have you ever tried mining those for institutions? Because very often, you know, my email address is at Virginia. That's a pretty good clue. That's my institution. I was just curious whether that had been, well, first of all, probably the same people that give the institution didn't give their email address to, but just a thought.
They only got one email address from each submission. So just the person who submitted, and shockingly, very many Gmail. They all work at Google. We found it.
So picking up on Matt's, he's sitting there frustrated at the moment because we're getting bogged down in affiliations when there's so much more to metadata. I think nevertheless, this is, if you like, a useful test case for the general principle, which is, you know, free text bad, cross references or references to canonical definitions good. And, you know, those of you who are in the geosemantics symposium yesterday, I showed some horrible code on the screen, but which was some RDF stuff. But that was the principle that we're really trying to grope towards there. And if we can knock it off through you know, and demonstrate the principles around things like organization identifiers and ORCIDs and that, then the principle gets, I think, propagated through the whole metadata system.
Yeah, I totally agree, Simon. And I think one of the reasons I brought that up was because I was thinking about, you know, we're basically building a governance structure for these types of identifiers that allows them to be managed in a way that's community endorsed. And I think we need those same governance structures for lots of the other metadata structures within our world, but there's many more of them. And I think it's, so people and affiliations, you know, I said that's easy in the sense that people are very motivated to get that credit and to have those linkages. And they're less motivated to, say, make sure that their 17th variable within their 13th table of their data set has an attribute definition that's linked to a term that defines the semantics of that attribute. And I think we need to figure out a way to build governance systems that let us have similar lists of things in control vocabularies, regardless of what level of formality we have with it, but some level of formality beyond where we are today. And so I'd like to continue that conversation and figure out how we do that. I mean, the whole semantics committee has been focusing on the ontology registry for vocabularies for quite a few years now, and it's just not seeing widespread uptake in the metadata records that we encounter. So it's really interesting trying to figure out how you build governance around these, I would consider much more esoteric, but still really important parts of the metadata.
So we had a nice talk today by Kai, you know, sort of connecting the earth to the biology. You got any thoughts over here about metadata that you can bring us from the biotic part of the business? Sorry for putting you on the spot, but it comes with winning awards.
No worries. I wrote down in my notes free text bad, cross-ref good. Thank you, Dr. Cox. I think that's a good just a summary, I guess, that like if we, as was just mentioned, if we can't even, you know, get these affiliations right, you know, what's the 13th column of your second spreadsheet, you know, looking like? In the life science world, it's hard to say because it's so varied, right? There's medical domains, there's environmental domains, they're very different. They often aren't overlapping. It really depends on the field, some better than others. In my own particular domain of marine microbiology, there's been an uptake in the use of terms from ENVO to annotate. We have this thing called the Genomic Standards Consortium. I'm not sure if anyone's familiar with that here, but it's basically like a working group to kind of provide some really basic or semi-basic metadata to ensure that genomic standards are using some sort of at least controlled vocabulary. Now it's preferring the use of environmental ontology terms, but it's helped, and it helps to bring data into future systems where we can actually, you know, search on these terms, ideally within an ontology like ENVO or something like that. But yeah, it's a grind trying to get people to do it. But I think that if in the future we can mobilize data using ontology terms, or even just controlled vocabulary terms in ways that people aren't used to seeing, it might provide the motivation for them to really kind of take it to the next level and actually comply, so to speak.
Thanks. Okay, any other thoughts, closing thoughts or opening thoughts or?
So this really is a general question, and I don't know how to measure it, so I'll leave that up to you guys. We have a relatively narrow barn door on our repository. I mean, you can't get in unless you meet the checks. And some other repositories are more open-armed and will take anything with a low barrier for submission. I've heard people who fund us mention that they appreciate quantity, and I've also heard them say they appreciate quality. Do you have an overall impression, is adding more checks, is that perceived by the community as an impediment or an enhancement?
No, it's a really good question. I think that the community doesn't exist as a monolith, so it's probably got lots of answers. Within the Arctic Data Center community, where we have fairly strong requirements, we have a similar check system that you guys have for LTR and EDI, we definitely encounter resistance and people that are frustrated, but they also appreciate the quality of the object that goes in there. So I think on the day that their report is due, when they're not getting their next funding increment because they haven't satisfied their metadata deposit, they're pretty frustrated with us. And then, you know, when they're looking for data the year later, they appreciate having that extra structure. So we definitely get feedback in both directions. Mostly people, as long as we make our expectations clear and they know about them ahead of time, I think people are pretty good about it. And they get frustrated when it's hard for them to satisfy the requirements we put up, like when the process for doing it is difficult. And so as we turn the crank on the quality sort of screw, I'm guessing we might get more resistance, but we'll see.
I just want to ditto that. We hear from synthesis working groups that they love using LTR data this way, but that the contributors grumble a little bit.
So at DataSite, we work with about 2,000 repositories, and some of them are so rinky-dinky, and they don't have a lot of resources. And we found if you can tie incentives of saying, here's what you're going to get down the line, here's what's going to happen if you do this, then there's more likely to have uptakes. If you provide some carrots and really let people know of the benefits of making those improvements.
If this is near the end, I just want to say that there's 2 more metadata sessions after this. It would be nice to hear from Matt and Margaret what they plan to accomplish in those 2 different sessions, if we have time.
There's also Sean's metadata evaluation session is the next one. Is that one that you're talking about, or? Oh, that one.
The metadata database one is all about free text, bad, prospect good.
And actually, there is a little EML thing plug again for what project we're trying to standardize how people actually create EML. What feature? Oh, sorry. In that, I'll make a plug for one of the talks in that session. Most of it's about the metadata database, which is generic, but there is one talk in there about what we're calling the EDI profile for EML, where we actually don't use all of EML that's possible because it's crazy complex. But we've discovered that people are using, 40% of it, and we're trying to kind of converge on a set of elements. There's also a poster about that tomorrow night.
Okay, so at this point, does that help your decision-making process, Bill? This is the last metadata.
Well, that's mine. It's about tools that support data discovery.
Okay. So, so one of the things that we're doing in ESIP now is having the flashing light. takeaways. So is one of the takeaways from this session that this cross section of the scientific earth science community or other communities thinks repositories should be helpful when they're in helping you improve your metadata? Force you to do it? Okay. And so that was I'd say, what was that, 15%? So who are the no's? Volunteers, so we should avoid volunteer contributors, I guess. Okay, well, thank you so much for coming, and thank you for the questions and the discussion. I hope this was interesting. We'll be talking about roars next winter, and this winter, yeah. So anyway, have a good week.